Hello. Today we're going to talk about um, forecasting of greenhouse gas emissions in futures, and we're going to cover, the how you specify what is generated, and also how you can apply constraints both on the absolute quantity of greenhouse gases, or more usefully, on the greenhouse gas intensity. So that gives you the possibility of cutting out production where let's say you're generating more than 100 kilos of CO2 per barrel of oil equivalent. And we're going to demonstrate it with the same standard demo model that we used in our earlier video about fuel and flare and power. So this is the standard futures. One of the standard models is a model with approximately 200 wells and a reasonably complex network. And what we've got is we've defined, we've got power requirements, power consumption defined at various pumps and compressors. We've got flare, and we've got power generation node. And at this power generation node, we're going to specify the greenhouse gas emissions. And these are specified here. So what we're saying is that the gas that comes to power generation, that's burnt for power generation, we're going to track the emissions from that. The reason for this is that by and large, you generally do not want to track the emissions for all the gas, because you don't count the CO2 for gas that's sold. So that's why it's defined. You can define it at various nodes in the system, but you can define it at any number of points that you want. And there should be similar greenhouse gas emissions defined at the flare, and that's easily set up by, again, specifying that it's a source of greenhouse gases, and you can specify specific emission values, so many tons of CO2 per kilo scuff, so many tons per barrel, but here we'll stick to the standard of calculating it from composition. Okay. And we'll start with a forecast where we just generate it, and then we'll move on and demonstrate the effects of putting on a constraint on the greenhouse gas intensity. So when we run the forecasts, what we'll see is we've got greenhouse gas emissions in tons of CO2 per day, and it's also reported in cumulatives. So this is in tons of CO2 equivalent. So total of 4.6 million tons of CO2. And that comes from the flare node has 340,000 tons, and the power generation accounts for counts for the remainder of the 4.2 million or so. Having defined the generation of CO2, we can use the future solver to impose limits. The simplest limit would be to put a constraint, to put a maximum limit of so many tons of CO2 per day. But it's rare for there to be such a hard limit. So instead, what we're going to demonstrate here is we're going to put a limit on the intensity. And this is done by, at our sales point, so this is the node, this node called sales is defined as being a sales point, which you have any number of them. But here we've got values and costs for production, and we've got a cost per CO2. And here we've got a cost per a ton of CO2 has a cost that's equivalent to 20 barrels. So in other words, we are limiting if that barrel of oil equivalent is responsible for more than 50 kilos of CO2 emissions, then the end result is that it's, in terms of the objective function, it'll be more negative than positive, and so that production will be shut in. And an important point to note is that the solver takes into account all the ramifications, all the aspects of the CO2 emissions. So if a particular well has got a high water cut and the resultant water needs pumped, and this consumes power and it consumes fuel gas, the solver will be able to work out the precise amount and will then calculate the appropriate combination of water cut and lift gas requirements and so on, at which the production ceases to, it violates that intensity limit. Now but what we need to do for that is we need to send the CO2 from that to sales, and so that's what we do to generate the second forecast, imposing a greenhouse gas intensity limit. It's got a plan change with a greenhouse gas limit, and that plan change directs the power generation output, i.e. the greenhouse gases, towards sales, and so it then is counted, and the intensity limit is applied. So we'll see in terms of that there is a difference. This is the forecast without the limit, and this is the forecast with the limit imposed. And in terms of the result in terms of oil, we'll see it's very small. We can give the total. You can see it more clearly on the cumulative. So we'll see that the intensity limit reduces our oil production by approximately 3.5 million barrels, our oil cumulative. and that's reducing the CO2 emissions by approximately 200,000 tons. Should be noted that similar to power requirements and fuel gas consumption, the greenhouse gas emissions, it's included in the standard plots, and it's also included in the standard export to Excel and so on. Thank you for your time.